Hey, welcome to Flight Test. I'm David, and today we're gonna build a Tricopter 2.6 HV with wooden booms. These are 12mm booms instead of the normal 10mm booms I normally use, and this is gonna be a little more robust. This is actually gonna be my beater Tricopter, so I'm gonna fly into stuff and make it survive. The thicker booms are actually nice because they don't twist as easy, which gives me a little more stability in the rotational axis. It doesn't start oscillating at weird frequencies as easy as the wooden 10mm booms. So let's get cracking. We start with the booms. We're gonna cut these to size. And on this Tricopter, I'm gonna use 35cm booms on the front. So let's mark that up, 35. We just cut those to start with. On the Tricopter bodies I made, this is made for 10mm booms to get that perfect 120 degrees between the arms. Since this is a little bit thicker wood, it actually kicks back the front arms a bit, which isn't a bad thing actually. That makes the props go out of the view a little better, but we have to compensate for that by using a slightly longer back boom. So make the back boom about 2 centimeters longer. So go with 37 on that. You can use different length booms for different purposes. I like the 35cm booms because that gives me the optimal swooshiness I like. It feels really good with that arm length. I've tried smaller ones, but they get a little more twitchy and a little more sensitive to the wind. And the longer booms make it a little bit too sluggish. It doesn't let me really go into that fast turns and feels a little bit slushy. I don't know. Okay, so let's cut that. While you're cutting your arms, cut a 30mm long piece. That's gonna go in the front of the Tricopter body here later to stiffen up the frame. So don't forget to do that. Okay, so we cut the booms. Now we're gonna drill holes in both of the front arms. So we're gonna cut the hole at about 15mm in from the end. So what I do is I use a caliper and I take it here and I push it down and I drag it and make a mark on here. Then you do the same on the other one. Just drag it, you get a mark, and then you change this to half your width of your boom. So in this case it's 12.8, go to 6.4. You drag it this way to mark your center. So now you have a little plus there. I can actually exaggerate this with a pen. So that's where you need to drill your hole. Really simple. If you're in America, which I am at the moment, you need to use a 1/8 of an inch drill bit. If you're in anywhere else in the world, use a 3mm drill bit. If you have a drill press, this is much easier. Otherwise, be over a corner or on top of another wooden item. Bring a scrap piece here so you don't drill into your finger or into your table. We need to score the back boom because it's made for 10mm booms. We need to score it a bit so it fits in here between the screws. The easiest way to do this is just put it here, use a pen, mark your spot on both sides, and then use a saw or a file to do your grooves. So I'm going to use the saw. Make it big enough so the screw actually fits in here. So I'm going to use a file and just go over it quickly like that. Yeah, it's going to be good. Test fit it, make sure it works. That looks good. Okay, so we're going to put the frame together now. Start with the back boom, or that's going to be the most difficult one to get in place. So we want to use long screws for this, really long screws, because we're going to mount the anti-vibration dampening system on the bottom here later. So fit that, like that. Then we're going to put the front arms in. We're going to use 20mm long screws on this. So just insert that through the hole, through the arm, down in the bottom plate. Flip this over and tighten these screws. Always use luck nuts or Loctite when tightening these nuts down. Otherwise they can come off during time due to vibrations, which is not good. At this point you don't have to over tighten the arms, just so they stay in place. Insert the screws in the front of the arms, the screws that actually stop the arm from going more forward and locks it in place. Again, always use luck nuts when you can, or at least use Loctite on your nuts. Be sure to move your arm all the way forward when doing this step, because it's easy to over crank these otherwise. We're gonna come back and fine adjust this later, just so you don't destroy anything. And when you start feeling that it's getting tight, that's time to stop. This mechanism actually makes it tighter when you get to here, so it stays really well in place until you hit something. So during flight this will not move. Okay, next step is to fix the motors. We need to cut these ridiculously long shafts, and to know the distance we're going to put a prop on there and then compare with the luck nut and just make it a tad longer than that. Here's a good tip when cutting these. Use tape. Take a piece, shove it over the motor axle. This way the filings, the metal filings, doesn't get into the motor, which is really bad because there's magnets in there and that can ruin your motor. We're gonna cut this using a Dremel. You can use whatever you want, a hacksaw or whatever. I find this most convenient. Okay, marked it. And now I'm gonna cut it. I recommend using safety goggles because you only lose your eyesight once. There's a flaw with the DC750 motors, and that is these wires. You see, they're just going straight to the motor bell, and if this flexes too much, that cable is going to break. So what I do is I remove this and I put some glue on there, so I reinforce it so it doesn't break in mid-flight or in a crash. So remove that and mix up some epoxy. I use 5-minute quick epoxy. That's what we had laying around. Do not use hot glue. Any heat resistant glue is good because the motor windings does actually get warm when you push it really hard. Okay, mix together. The longer you mix, the better the glue joint generally. So mix for about 30 seconds. And what I do first, I turn the wires upwards, and that spins around, and use something to apply the glue underneath here first. Nice thick bead here. Then push the motor wire down, so it squishes it out, and put another piece on top of it. Then I drilled a little stand here from a scrap piece of wood, so you can set them there, let them dry in the upright position, and do the same with the other two motors. Now that these have dried, we can solder on the bullet connectors to the motors. If you don't have a pair of helping hands, you can actually get away with just drilling a hole in a board and putting the bullet in there and then solder it to place. But I'm going to use the helping hands to make it easier for you to see. The first thing you need to do before soldering the bullet is actually reload this solder here, because you don't know if this is the same mixture as your own solder, so you want to pre-tin them again just to make sure you get a proper bind. Otherwise you can get a cold solder joint, and that's not good at all. After that, you want to pre-tin the bullet connector. Add a healthy amount of solder inside of the bullet connector. When joining these together, the important part is to have both pieces properly heated up. This is the biggest part, so make sure that solder is properly flowing, then join them together. And keep it as still as you possibly can. And that's how you do a proper solder joint. So heat both pieces up to the same temperature, then join them together, and then hold them still. That's good. Repeat 8 more times. So when you put these back together, make sure that the shaft doesn't protrude from the bottom here. So because we're gonna mount these straight to the wood later, and we don't want them rubbing, because that's gonna create unnecessary waste heat and make your copter not fly good. So you can put it on the table, and if you can spin it freely without it rubbing, it's good. Time for the tilt mechanism. These two pieces are from a steerable nose wheel assembly, and what you do is you drill out the middle hole on one of them, so the rod you're going to use fits easy in here. The other one is going to be snug, so it's not moving. And you put these two pieces together, and then you put the rod through it here, and what that does is lets this piece move independently of the other, and it makes the rod stay in here. You can use a screw or a carbon fiber rod or a metal rod, doesn't really matter, as long as you glue it or you make it stay in place. Then this part here is attached to the servo. So when the servo moves, this piece will move, and the motor is going to be attached on top of here. So let's get cracking. And make sure when you fit these two pieces together that they actually move without too much slop or too tight, because you don't want to put unnecessary strain on the servo. To do that, you can actually sand the middle part here if it's too tight. In my case, they were actually really nice, but sometimes the tolerances are off, so it actually makes it rub a bit. So make sure they're moving freely. And now I'm going to cut this rod to length. Okay, next step, we need to sand this control horn down, because otherwise it won't lay flat against here. So just go back and forth on the sandpaper. To make this easier for you when you assemble it, you can glue this, make sure it's in the center, and then we're gonna drill two small holes to actually screw in the control horn. Gluing it makes it so much easier to line up. So I'm just gonna add some glue here. That's actually a tiny bit too much. You don't want too much glue, you just want it to stay in place. Just dab that off. And then make sure it's in the center here of the screw that you have in there, and everything lines up properly. So that's gonna make it stay in place while you drill the tiny two holes in there. Use a small drill bit. A very small drill bit. Pick the holes that seem to have the most material at them. It depends on your control horn. I'm going to use these two holes because that seems to have the most amount of material around it. So I'm just going to drill this. Then take two of these screws that usually comes with smaller servos and just screw it in the hole. Okay, time to remove the excess material around here. You don't want it to rub anywhere, get caught. I normally use a Dremel, but you can use a pair of pliers or sand it down or whatever. It's good enough. So next step is to take the servo, and we need to modify that to actually fit in here, because this is going to sit against the boom, and this is also going to sit against the boom, but it doesn't fit. We need to cut off that arm and add a plate here to get the proper distance. So that's what I'm going to do, and as usual I'll be using my Dremel. Okay, so I cut the servo. Trouble is, it's now too low. And this all depends on your servo size and where your spline is and everything. But in this application, it's perfect with a 1.5 millimeter thick piece of plywood. Just put it on here and it's perfect. So I'm going to glue that to the bottom here. You don't need a lot of glue, you just need it to stay in place. Now it's time to mount the motor on here. This hole setup is really good. It fits perfectly over 2 of the holes here, but you need to drill a 3rd hole in the middle on the other side, like in the middle of here. And then you can actually fasten this using zip ties. So I'm going to do that. Like that. Now while we have the drill out, we're going to fasten this to the wood later. And these holes here are not optimally spaced. It should be, you should be able to see the wood on both sides. So what I'm going to do is enlarge these holes with a drill. We're going to strap this to the motor mount here using a normal zip tie. Mount it loose to start with until you get all the zip ties in there. The zip ties will break off in a crash, absorb a lot of energy, save your motor, and save it from making the output shaft crooked. It's better to have a weak point that you designed rather than the crash finding your weak point for you. And that's your tilt mechanism. Time to mount the tilt mechanism to the tail of the tricopter. To do this, we're going to use 4 zip ties. The first zip tie you need to bend a bit because we're going to have it go through the bottom of the tilt here. There's a sufficient gap in between here so it actually doesn't rub or anything. And then on this side it's super easy. You want to alternate the direction of your zip ties so the force when you pull it down is evenly distributed. Now mount this as far out as possible. If your zip tie is too short, you can simply take another zip tie and pull it through and then connect both ends. So you want to mount this as far out, flush with your end of the arm. Do the same on the other one. Then pull these tightly. Should fit very snug. Have some good tension. And the zip ties actually grip into the wood, making this really hard to move. Time to mount the servo. You want to center the servo using your radio before you do this step. And also, the tricopter has an odd number of propellers, so you need to counter that yaw motion. So put the servo slightly offset instead of having it perfectly straight on the spline. So this should be angled to the right if you look from the back. Again, use zip ties to mount the servo to the boom. Use multiple zip ties. You don't want this to move during flight. Alternate the direction of the zip ties to distribute the force properly. I usually go with 3 pairs of zip ties on this particular setup. The zip ties really bite into the wood, making a really strong connection. Instead of making this tilt mechanism, you can actually buy this one that Chad designed. It's very nice. So check out the Flitest store for this if you want to save some time building. Time to mount the front motors. We're going to use zip ties here again, since we want the energy to be absorbed by the zip ties and break in case of a crash. So what you do is just thread the zip tie through those set of holes, and then you thread it on the opposite side on the back here. So these 2 holes, like that. Then you put it on the arm, and then just zip it down. That is properly on there. Just 2 zip ties, as simple as it can get. I learned from experience that the zip ties save you so much time and headache when you're out in the field and you have an accident where you have a prop strike or something that would normally break your motor mount. This actually just pops off and you can use a zip tie again and just bolt it down and you're good to go. So it saves so much time and headache. I strongly recommend using it. This is a very simple landing gear, just cut out really quick. I mount these using zip ties again because they as usual, absorb the energy when you have it too hard of a landing. The reason I'm mounting the landing gear now instead of later is because it just saves me from having other stuff hitting the table. This elevates it up and makes it easier to work on. Next step is to bend a wire this shape, a U shape with two 90-degree bends on it. This is for the vibration dampening system, and to do this you need a piece of wire that's 1/16 of an inch thick or 1.6 millimeters for those of you that live anywhere else but the US. What you do is you need to cut a 120 millimeter long piece to start out with. So all you do is just cut that. Next, bend the edges 15 millimeters in, which happens to be the width of the mouth of these pliers. So you just bend them the same way, so just like that. Then use a smaller piece of pliers and just grab it. Then we're going to bend it this way. So move slowly, put on your favorite TV show, sit down, relax, do this. It takes some time and it gets frustrating if you do it in a rush. Just sit down, have a good time, and shape it slowly, a little piece at a time, to get that nice round shape that we need. And by the way, I will not make one of these for you. You have to do it yourself. Just learn it. Just suck it up. Here's a straw. And then just shape it generally. So the distance between these two should be 45 millimeters. That gives you proper space for your battery on your camera tray later. Okay, now that you bent your wires, we're gonna put them in these holders. This is the top front piece. And all you do is just you take these pieces, you slid your wire in here in the right way, and put the lid on. Now these clamp down on the wire. I'm going to screw these in place here so they don't move while I'm doing the other things on the build. Now if these wiggle a bit, bend them a little bit more so you have some tension on there, because you don't want them to be sloppy later. You want them to be nice and crisp. If you bend it a little bit more, either way, I'm just going to bend this 90 degree a little bit more here, and then bend it slightly more this way. This should ensure that it stays in place properly without any slop in there. So you can feel it again, and now it's nice and stiff. These pieces are going to be on the tricopter later. That's why we use longer screws on the back and the front of the tricopter body. But for now it's just easier if it's held in place with just shorter screws. Now that these two are done, I'm gonna put these on here and into that slot there. Then we're gonna take the other piece of this and push that and glue that in place here later. So that's how it's gonna be mounted together. Now we just have to do that. What we're gonna start with is take this one, take these small little things and push these into these slots here. This is to hold the camera later. I'm gonna put a little tray on here. But they also, when you push these through, they're gonna protrude on the bottom here. And what these do also is help hold the bottom piece in place. So what you do is you put that on here, and you squeeze it together. That makes it perfectly aligned and almost one piece. So this is the top piece here. I took it apart again because we're gonna glue these pieces on here. And these laser etched lines is where you need to glue these. Make sure you put them in the correct orientation. So this first piece is gonna point backwards, so to speak, and this piece here in the back is gonna point in the opposite direction. So they're gonna point towards each other. So first off, we're gonna glue these in place, and don't use too much glue so it squirts out everywhere. Just a dab in the middle, and then put it on the lines here, making sure everything is nice and straight. We can add more glue later on. But this is just to make sure everything is where it's supposed to be. Do the same with the bottom piece. We're gonna add this spare piece here to the middle to stiffen the whole camera tray up. Use some glue and just, doesn't really matter exactly where it is. It's just gonna be roughly in the middle of the other two here. And squish that in place. This is gonna stiffen up the camera plate a tad more. Now that you glued in the bottom pieces, take this piece that's the camera tray and put that into place, just temporarily. We're gonna glue it later, but it makes it easier. The next step is we're gonna mount these in place here, and this is the tricky part. We're gonna glue this piece everywhere here at the same time. And this is a bit tricky, so have clamps ready, have your glue ready, have something to wipe off excess glue if it would squirt out so you don't get it everywhere. Make sure when you put these in place that they face the correct direction. This is supposed to be in the front, this is supposed to be in the back, with the back end, the thick part pointing backwards. But make sure this piece, the rounded front piece that looks like the front of a tricopter, is pointing forward. Okay, let's glue this. I'm using medium thick CA. You can use thick. I wouldn't recommend using thin because it gets everywhere in this step. So just apply a good measure, more or less everywhere. You can add a bit more here. It's going to squirt it a bit. Okay, now make sure that these tabs slot in the front here first before anything else gets glued. So hold that up in the air and squish that together. Now comes the fun part. Take the clamps, clamp down, make sure everything is straight. And the most important pieces are these, obviously, so start with those. Then we can add one in the middle here. And then I'm gonna use one of these clamps on the front here. That's just gonna squish it a bit in place. And you can help with your hands a bit here to make sure it's nice and flat. While this dries, you can listen to your favorite audiobook or look at an episode of Flight Test. You can use thin CA once it's clamped down and just add it to the pieces here. It's going to saturate the wood and wick into the place that the glue didn't penetrate earlier. Okay, let's take the clamps off. It's dried for about 5 minutes. Let's inspect how it looks. If we have to make any adjustments. That's really stiff now compared to what it was earlier. So the glue is obviously set pretty nicely. So that's a camera tray for you. And these angles you see here, don't worry about that. That actually is a good thing, because when you screw it in place, it's gonna create tension down to and make sure there's no slop in the wiring, which is really what you're looking for. It's supposed to be nice and stiff. Next, we're gonna glue this front piece here. We don't actually have to take that off. You can just use thin CA and squirt it on the sides. There's not a lot of load here. Just let that wick in between each of these teeth that sticks up here. And that's actually all you need. It stays in place and it's gonna be pushed down. There's no force acting on it later. So that's your camera tray ready. Now you can put it on your tricopter. Remove the screws and mount the camera tray on the tricopter. Mount this piece in the middle of the two frames in the front here. This considerably stiffens up the frame. Done. Now that the camera plate is screwed on here, we need to shorten these screws. If you have the correct length, you don't have to do this, but I was lazy and I didn't want to find some correct ones. Correct length ones, so I'm just gonna cut these off. Oh my god, sparks! Time for the electronics. So, we need some speed controllers. I'm gonna use these. They're the F20A from Hobby King. And I'm gonna reflash them using the Simon K software, which makes them perform better because they respond faster. So what I did is just cut up the back here, and then I made a little programming header here. So I just push these on the pins here, and then I use an AVR programmer to reflash the software. We're not gonna cover this in this tutorial. We might do a tutorial on it later though. What I did here is just added some bullet connectors on each end on the speed controller and some wire mesh. It's just going to make it easier for me to move these around if something would happen. I'm not going to show you how to do this. It's an unnecessary step. Just solder on some bullet connectors and you will be good to go. When setting up the tail here, you need the cables to be able to move freely so it doesn't hit anything. So this is the stop. So that moves really nice. But if it's hitting the servo, causing unnecessary bindage, you have to take care of that. I made a little Y harness to some bullet connectors, and to solder this connection here I just stripped the wires and put them together, and then used the technique I used in this video, and I wrapped the whole thing with a strand of wire and then soldered it to the connector. But you can actually buy a similar cable to this from Hobby King, I noticed, which is pretty nice. So that's a pretty good setup actually. Doesn't cost much either. Okay, so now we installed all the wiring here. One thing you really should think about when building this tricopter is when the tricopter folds, make sure there's no wires here. Make sure everything is zip tied down so it cannot get in this area. Otherwise you will have a tricopter that also works as a wire cutter, which is not good. Now it's time to install the KK2 board I'm going to fly on here. And to do that, I'm going to use some foam tape here. I don't know where we get this. I found it in Chad's basement, so we can probably ask him, but he's not here. So don't be mad. Anything vibration dampening will work. So what I do, cut little squares of this. Yeah, like a square that size. And I usually put one on each corner here so you get a nice broad stable base. And then I used some double-sided sticky tape, so I'm just gonna mount this on the copter. Make sure it's nice and straight. I'm using the KK2 board. You might use something else. Just look in the manual, set it up properly, make sure everything works. Leave the wiring really messy to begin with. You can fix that after you know it flies. So clean everything up later. Make sure that the motors spin the correct direction, and do that without the props mounted on them. A trick I use is I just lay the prop on here, and when it spins up you can see which way it's spinning. That works really well. So otherwise use the tape method or whichever method you want to use. If the prop spins the wrong direction, just switch two of the motor leads and it will spin the correct direction again. Yay. Correct. Correct. Nice. One thing about the DT750 motors is whenever you tighten down your propeller on it, it can sometimes slip because it's very slippery, this plastic. And if you over tighten it, it's going to pull up the motor shaft and push against the bearing, which is going to make it run a little too tight. It's going to draw a lot of current, which is totally unnecessary. It's going to bind up. What I found is if you just cut these out, you can put these on here, and it actually gives you a bit more friction, which is really nice. It makes the prop not spin as easily. So you can actually buy these on the Flight Test store if you're using the DT750s. One important thing is to balance your props, because that's the main thing that's going to lift your tricopter. If you don't know how to balance your props properly, look for our tutorial. On this tricopter, it's the HV version, so I'm going to use a 4Cell 3000. Okay, so now time to mount the GoPro. Depending on which GoPro model you have, if you have the newer GoPro 3, you can have the strap underneath this portion, which makes it nice and snug. If you're using a GoPro 1 or a GoPro 2, use these two holes. That makes it wider, which fits nicer over the GoPro 1 and GoPro 2. We got a nice downward angle. If you don't like a downward angle when you fly, you don't have to mount this piece at all. You can have it flat if you want to. So that finishes up our tricopter build. We're gonna go out and fly it and see if it works properly. Thanks for watching. Go to flytest.com, rate our articles, read stuff, post your tricopter builds. I like to hear your comments. Just write them in the YouTube or on the page, or send it as an email. We read everything. So thank you, and I'll see you next time.